Okay, can you give me, I see there's 4 people watching right now. Can you just put a quick comment in to let me know if you're here and if you can hear my voice? Oh, excellent. Thanks, Fabio. Okay, so this is good news. We are working, it's live, and it's happening. So this is just a live session. Essentially, we're trying to make a fit block here so I can answer any questions you have about the material. So how this is going to work, and we're going to try and do this every week, is as you come in, just put your question in the comments, and then as you're putting down those questions, I'll go and answer them. Feel free to stack up a number of questions. If you've got 3 or 4, you can put them all down there, and then I can just answer them in the order of the of the questions up here. So who's got the first question for me? Hopefully someone's got a question. How is everyone finding energy as a unit? Was the first lesson fairly straightforward? Is it making sense? Okay, so does anyone have I see your 2 comments there, so it's making sense. Is there anything that was unclear, any of the practice problems that you had difficulty with? Yeah, of course, Fabio. Any question you have? Question 7. Here we go. Okay, excellent question. So, the minimum speed you'd have to throw a ball straight up in order to reach a height of 10 meters if you release the ball from 1.5 meters above the ground, and then what's the speed when it hits the ground? Okay, so for this question, and actually our next week's lesson, I've already done the video, I just haven't posted it yet, but we're going to go into it, so for those of you who are watching now, you'll get a bit of a head start. So like any question, it's always a good idea to start with our drawing. So for question 7, here's the drawing. You're throwing a ball straight up, and you're releasing it 1.5 meters above the ground. So this point here is 1.5 meters, and you are going to be throwing it to a height of 10 meters. So the ball is going to go this high to the 10-meter point. So with any of these problems here, a good place to start is with this basic idea here, that the sum of all your initial energy is going to equal the sum of all your final energy. And then the problem is to identify what are the initial and final energies. So initially, you are going to be throwing it up. So to start with, you're definitely going to be having some kinetic energy. And you also have a bit of potential energy because you are 1.5 meters above the ground. Now, in the end, if you're reaching 10 meters, we know from kinematics that when something is at the top of its arc, it stops moving. So it's not going to have that kinetic energy, and especially because we're throwing it straight upwards. So it's going to completely come to a stop at the very top of the arc, and so that means it's going to have no kinetic energy. It will just have the final energy. So we have potential initial energy and potential final energy, and then we have initial kinetic. And now it's a question of kind of solving these out. So with one, what we're going to have here is 1/2 mv initial squared, and that's essentially what we're trying to solve for the first part of the question, plus mgh initial equals mgh final. And in this case here, and it's often going to be the case when we have both kinetic and potential and there's no work being done. Work is going to happen in about 3 weeks, the topic of work or change of energy. So we can cancel out all these m's because they're in each term, and so here we are ready to solve. We know that we know 1/2 is a constant, we know g is 9.8, the initial height's 1.5, again g is 9.8 for the third term, and h final is 10 meters. Now this is one way of solving it, and we could go ahead and solve that. So if we do the algebra for this, we're going to have 9.8 times 10 minus this term here, so minus 9.8 times 1.5 is going to equal 1/2 v squared, and this would be 9.8 times 10 minus 1.5 is 8.5. Minus 8.5. Multiply that by 2, and then take the square root, and that gives us, anyways, it gives us the answer that we have here. So 12.9 meters per second. So that's the answer that we have up here. Now I wanted to show you a little shortcut. So we're going to do this, you'll see this in next week's lesson, but I'll give you the heads up now. Where we put our 0 point. So for this question, we can see that we said, okay, this is the ground. This is 1.5 meters above the ground, and this is 10 meters above the ground. Where we put that 0 mark is completely arbitrary. So if we were in class, we might measure it above the desk, we might measure it above the floor, we might measure it compared to the ground outside. That's completely our choice. So what we can do, instead of having this where we have some initial potential energy at 1.5 meters and we have some final potential energy at 10 meters, why don't we just change our 0 point? It's completely up to us where we decide 0 is. Well, what's the benefit of doing this? Hopefully you can see the benefit. If we try and think about what our energies are, so I'm going to solve this the second way here, and we know that the sum of our initial energy is going to equal the sum of our final energy. Well, do we have potential energy at the beginning now? And the answer is no, because we've said that this is our 0 point, and this is where the ball is starting, so there is no initial potential. Now, there's just the initial kinetic, and there's going to be the final potential. And what would this h be for our final potential? Well, it was 10 meters, but now we've shifted the 0 mark up by 1.5 meters, and so now the difference is going to be just 8.5 meters. So now we're going to have, again, our m's are going to cancel out. We're going to have 1/2 v initial squared equals 9.8 times 8.5, which you see is the same thing that we got right here when we had 9.8 times 10 minus 9.8 times 1.5 gives us 9.8 times 8.5. It's the same thing mathematically. It's just giving us, saving us a bit of time because we only need 2 terms instead of 3. Both will get you the right answer, but this is a bit easier. Okay, what's your next question for me? Okay, well, if we don't have any more questions, then I think this will be a very short fit block or a very short Q&A. So I'll give us another 20 seconds or so. If you've got another question, please put it in the comments. Otherwise, we will call it a day. And of course, you can feel free to email me any other questions you have, and I can just send you an individual message to answer those. Okay, I think that is a wrap for the week then. So thank you very much. I see Fabio's here. I see Alex is here. I'm not sure who else. I see that there's 4 people watching, but someone else is a silent observer. So yeah, thanks again for coming in. It was a very short session, and feel free to email me if you have any other questions about the homework or about any of these questions you have here. Oh wait, kinetic and potential when he's releasing the ball. Okay, so Fabio, I got your question here. How is there both kinetic and potential when he's releasing the ball from 1.5 meters? So in this case here, you can, in terms of our kinematics of this problem, in order for it to reach that top height, if we were going back to kinematics, we would be looking in the y direction. We would have our d is going to be 8.5 because he's going to go up by 8.5 meters, right? We're going to have our initial speed will have to be something. We don't know what it is yet. We're going to have our final speed will be 0. Let me just move this up here. Our final speed will be 0. Our acceleration will be negative 9.8, and we don't know what our time is. But we can see here, if we think back to kinematics, it's definitely going to have some initial velocity. So when we're thinking about when we're having our initial start point, it's sort of the exact moment. Think of it as like a millionth of a second after the ball has left your hand. So at that point, it does have an initial velocity, and at that point, it is 1.5 meters above the ground. So if it's moving, it's got kinetic energy. If it's above the ground, it's got potential energy. Now, again, like I showed with that second version of the solution, if it has potential energy or not, that's an arbitrary decision for you to make. So if you say that the 0 mark is the ground, then it has potential energy compared to the ground. If you say that the point of your hand is the 0 mark, then you're saying that it's going to end up going 8.5 meters above your hand. So in that case, you wouldn't have potential energy. So whether or not it has potential energy just depends on what you call your 0 point. And in terms of having kinetic energy, if it's got a velocity, it's got a kinetic energy. Does that answer your question, Fabio? Okay, perfect. If you have any other questions, quickly in the comments, or we'll call it a day. Okay, I think that's that. Thanks very much for joining this week, and we'll see you again next week. Thank you.